Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. So today is a continuation of our previous lesson. So we are still on finding derivatives of trigonometric functions. So we have question number 6 or example number 6 says that y equals to the square root of 1 minus cos of x divided by 1 plus cos of x. So if we solve this problem, you can also practice y equals to the root of 1 plus cos of x or divided by 1 minus cos of x. So the 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 method we're going to use to solve this problem, you can use the same method to be able to practice this problem. Okay, now, so whenever you are given a trigonometric function problem to solve, the first thing that should run to your mind is, can I be able to rewrite the problem in a way that I can bring in some derivatives that will reduce the problem into some compact form? If it's possible, then you can go ahead. If it is not, then you can differentiate, and after then you see how best to further bring in some identities to solve the problem. So now, one way that we can think of solving this problem is to use implicit differentiation. That is, we square both sides to get rid of this square root, right? And use quotient rule, the quotient rule, because if you get rid of this square root now, on this side of the equation, you will have 1 minus cos of x divided by 1 plus cos of x. So it means you use a quotient rule. But I don't want to use this particular method. I want to use a different method. Now, in our trigonometric lesson, we derive some useful identities from the double angles identity, especially for the double angle identity for sine and cosine. So we know that cos of 2x is equal to cos square x minus sine square x. So we know this one. And this one was derived from cosine of a sum, right? So if you check the video, you can see how we derive this particular identity. Now, from this identity, now we can derive few other identities that can lead us to simplifying this problem before differentiating. So we know that from the Pythagorean identity, cos square x is equal to 1 minus sine square x, and sine square x is equal to 1 minus cos square x. These are Pythagorean identities. So we can replace this cos. So cos of 2x is equal to 1 minus sine square x minus sine square x. So what will we have? We have 1 minus 2 sine square x, right? Now what we see here is 1 plus cos of x. So if we send this, and also we have 1 minus cos of x. So if we send this term across, we're going to have 2 sine square x, positive 2 sine square x, and then this will be equal to 1. If it goes across, it becomes 1 minus cos of 2x. But here is 1 minus cos of x, and this is 1 minus cos of 2x. So to get rid of this 2, we can divide each angle by 2. So therefore, we will have 2 sine square x over 2 is just equal to 1 minus cos of x. So this is the first identity we want to use, right? It's very, very simple to do that. So the next identity we want to find identity for this particular denominator, right? So we've already gotten the numerator, which is 2 sine square x over 2. So from this same cos of 2x is equal to cos square x minus sin square x. So we can say cos of 2x is equals. So instead of replacing cos square x now, we can replace sin square x. That is, we say cos square x minus, so we put it in parentheses because of this negative. So sin square x is just 1 minus cos square x. So cos of 2x is equal to cos square x minus 1 plus cos square x. So cos of 2x is equals, so this and this can be added. You have 2 cos square x minus 1. So if this 1 comes across, we're going to have 1 plus cos 2x or equals to 2 cos square x. So we also have 1 plus cos of x, and here is 1 plus cos of 2x. So we can divide both sides by 2 again, like we did in previous problem. So it means that we will have 1 plus cos of x to be equal to 2 cos square x over 2. So this is the second identity. Now, if you actually know the identity for this entire expression, the square root of 1 minus cos of x divided by 1 plus cos of x, if you know that identity directly, you can just replace it. But we just needed to start from somewhere so that at least we can also show you few ways to identify these identities. So let's get rid of this now. So we have the two important trig identities. So y now equals the square root of, now remember each of them can carry their own, okay, let's maintain it like this. So 1 plus 1 minus cos square x is just equal to 2 sin square x over 2, and then 1 plus cos of x is equal to 2 cos square x over 2. So this 2 can cancel this 2. Because the both of them are square, we can rewrite it as sin of x over 2 divided by cos of x over 2 all square. So this is a square root. The square root can cancel that too. So y now equals to sin of x over 2 all over cos of x over 2. See how simple it is? But what is sin over cos? Sin over cos. The quotient identity. So, sorry, we are not differentiating. We have not started differentiating yet. So y now equals to tangent of x over 2. So we can now find the derivative of this particular function. So y prime equals to secant square x over 2 times the derivative of the angle. So remember the angle is x over 2, which is 1 over 2 and x. So the derivative of x is just 1. So it means this is just 1 over 2. So what do we get finally? We get y prime to just be equal to 1 over 2 secant square x over 2. So you see how easy it is? Okay, what if we also wanted to use another method? Let's try to use another method. What if we wanted to use another method? Say we wanted to use the we want to use implicit differentiation. So y equals to square root of 1 minus cos of x or over 1 plus cos of x. So we can square both sides. So y squared now will be 1 minus, this will cancel, cos of x all over 1 plus cos of x. So we can differentiate on both sides. So this one will give us 2y Then we attach y prime because this is the name of the function. Equals, we use the quotient rule right here. We hold the denominator first, 1 plus cos of x, and we differentiate the numerator. So the derivative of 1 is just 0. The derivative of cos of x is negative sine of x. So negative times this, negative is positive. So it's positive sine of x. Minus, quotient rule says we should use minus. So we hold the numerator now, 1 minus cos of x. And then we differentiate the denominator. So the derivative of 1 is 0. The derivative of cos of x is negative sine of x. All divided by the denominator all square. All square. So now we can simplify and solve for y prime as well. So sine of x times 1 is sine of x, and then sine of x times cos of x is sine of x, cos of x. Then this one, negative sine of x times negative 1, because this negative times this one. So it gives us positive sine of x. And then negative times negative is positive, times this one is negative. So this gives us sine of x, cos of x. So all divided by 1 plus cos of x all square. So erase this one. Remember, this is our answer. Let's put the answer right here. Y prime equals to 1 over 2 secant square x over 2. So this is our answer. In the first method we did. So now we can simplify. Sine of x and sine of x is 2. So it's 2y, y prime equals 2 sine of x. And then this gives us 2 sine of x, cos of x. All over 1 plus cos of x all square. So we can solve for y prime. That is, we can divide both sides by, or we multiply this whole thing by 1 all over 2y, so that we get rid of 2y from right here. So we have y prime equals 2 sine of x, or we can just factor out this 2. 2 comes outside. You have sine of x minus sine of x, cos of x, all divided by this 2y is 2y, then 1 plus cos of x all square. So there is something common in the numerator. So we have 2 sine of x is common, so we can bring sine of x outside. We're left with 1 minus cos of x all over. Now this 2 and this 2 can cancel. Now this y, from the beginning, y was just equal to this expression. So we can rewrite that y as 1 minus cos of x. So each of them can carry, if you have a, the square root of a over b, this can be equal to the square root of a or over the square root of b. So the numerator, 1 over 2, and the denominator, 1 plus cos of x raised to the power 1 over 2, times 1 plus x, 1 plus cos of x raised to the power 2. So you see that we can simplify. So this and this. Now the power here is 1, and the power here is 2. The power here is half. So we can simplify. See how we simplify. It's very, very easy. So we have y prime now to be, this is sine of x. So remember, if you have a raised to the power, let's say say you have x raised to the power a over x raised to the power b. When the bases are the same, it can be x raised to the power a minus b. So this base is 1 minus cos of x. And the same thing down here. So it's 1 now minus half divided by the same thing with this one. So it's 1 plus cos of x, 2 minus 1 over 2. So y prime equals, now sine of x, now what is right here? What is right here is just equal to 1 minus cos of x. Now 1 minus half is just half divided by this one, 2 minus half. So if you take half from within 2, you left with 1 and a half, which is just equal to 3 over 2, right? So this one now will be 1 plus cos of x raised to the power 3 over 2. Okay. The same thing that we did from the onset, the first method we used. We showed that sine of, let's say 1 minus cos of x was equal to sine 2 sine square x, the numerator, right? And then 1 plus cos of x was also equal to 2 cos square x. I think that was what we did, right? So let me recap. So we have cos square x let's say cos of 2x is equals to cos square x minus sine square x. So this now is 1 minus sine square x. So this will just give us 2 sine square x. So if we divide both sides by 2, all angles by 2, and then this one goes across, or let's say this one comes across, and this one goes on that side, it will be 1 minus cos of x, and this is sine square x over 2. So sine square x over 2 is 1 minus cos of x. So this is sine square x over 2. Okay, that one is correct. So if we were to replace this sine, it means you have cos square x minus 1 plus cos square x. So this is 2 cos square x minus 1. So if this cos goes across, so it's cos of 2x. So if this 1 come on this side, you have 1 plus cos of 2x. So this angle now we can divide both sides by 2. So it will be 2 cos square x over 2. Great. So I just want to confirm it. So now we have y prime to be sine of x. So this is just equal to this whole thing right here is just 2